I'm Jason Lewis.
I'm Thomas Mills.
Welcome to Climate Optimists. As a couple concerned citizens, we're on a journey to explore climate solutions and ways each of us can make a difference. So if you're a fan of the podcast and want to help be part of delivering the content you hear, consider joining our community of monthly supporters. You can feel good knowing you're helping empower people around the globe make a difference on climate. And all you have to do is head over to our website, climateoptimists.co, and click the donate button.
And while you're on the website, don't forget to take a moment to sign up for our monthly newsletter. It offers facts on climate solutions, perspective on climate news, and tips on how to make a difference. And if you are short of cash but still want to help us out, there is a possibility to help us reach a bigger audience by having your friends subscribe and rating us on your favorite streaming platform.
Great point, Thomas. So if someone asked you to name the most used material on Earth, what would your answer be? Perhaps not surprisingly, water holds the number one spot, but what about number two? Up until recently, I probably would have guessed something like, fossil fuels or food-related product, but the answer is actually concrete. And in 2020, the world produced nearly 14 billion, that's billion, cubic meters of concrete. And if you're wondering, well, what is that really? For context, we did some calculations here. And at that rate, you could make a concrete replica of Mount Everest in about 6.5 years, which is just crazy to me. So given how much we make of this stuff and the emissions that it's responsible for, today we're going to be talking about kind of the nexus of concrete and climate. But before we get into the details, let's talk about this week's Reason for Hope.
Yeah, Jason, the European Union just announced its Green Industrial Plan, which is intended to counter the US's Inflation Reduction Act and subsequently reduce the EU's dependence upon China. There's nothing quite like a bit of friendly competition to accelerate the green economy. And according to Reuters, the EU wants to ensure its manufacturing capacity is present to meet at least 40% of its needs for equipment required to decarbonize the EU, such as solar panels, wind turbines, heat pumps, and batteries by 2030. In addition, the plan also intends to streamline the permitting process for green projects and lays out a goal of reaching 50 million tons of annual CO2 storage by 2030.
Yeah, I thought that was an exciting bit of good news. Obviously the EU's been moving in this direction and really arguably is leading the way in terms of decarbonizing. They're ahead of the US. But yeah, I think this build out of, capacity to build things like solar panels, wind turbines, and heat pumps only really accelerates our transition to, a carbon-free economy. So yeah, I thought it was good news.
And I'm sure the whole coronavirus pandemic and the blocking of the Suez Canal and a few other things has spurred the EU to move in this direction.
Yeah, indeed. So our guest today to help educate us on the solutions to decarbonizing concrete is Chris Bataille. Chris has been involved in energy and climate policy for 27 years. In that time, he's worn many hats, including researcher, energy systems and economic modeler, project manager, analyst, writer, and managing consultant and partner. He's currently an adjunct research fellow at Columbia University's Center for Global Energy Policy and an associate researcher at the Institute for Sustainable Development and International Relations in Paris. He was also the lead author of the industry chapter in the latest assessment report released by the Intergovernmental Panel on Climate Change, which, for folks who don't know, is basically the Bible of all climate reports. Chris holds a doctorate in resource and environmental management from Simon Fraser University, and we had him on the show this past fall to talk about the buzz around hydrogen, and excited to have him come back and talk to us about concrete. Chris, welcome back to Climate Optimists.
Hey, nice to see you again, Jason.
Well, let's start you off with a basic question. When it comes to efforts to address climate change, what makes you hopeful?
Uh, to be honest, it's that we're finally paying attention to it. It's not a technology thing. We know how to basically eliminate CO2 emissions from our economy, but it basically it's a generational effort to kind of go sector by sector, process by process, and replace each one with a non-emitting version. Some of it's easy, some of it's hard, but it's a matter of focus and policy focus and investment focus and what have you. So that's what does make me, the fact that we are paying attention makes me optimistic.
Yeah, it definitely feels like there's a transformation when you compare it to even, a few years ago, the number of people, tuned in and really wanting to, see forward progress. Well, since we're talking concrete and cement today, let's for those who may not be super familiar with the two, let's talk about kind of what they are and how they're different.
Yeah, sure, absolutely. So, cement and concrete is one of my favorite topics besides iron and steel. I've been doing material decarbonization basically full time now for about 7 years. Before that, I was doing economy wide decarbonization. But because materials, electricity and hydrogen, everything's so central, I keep a tab on that. But cement concrete is the thing we use the most in the economy by pure volume and mass. Our buildings are made out of it, our infrastructure is made out of it, a lot of our roads are made out of it. You'd be hard put not to turn around you and not see concrete at any given time. uh, Infrastructure is about 48% of the concrete use,
Okay.
buildings and 45%. So it's kind of roughly half half. And the difference between cement and concrete is simply cement is what holds concrete together. Concrete is a mixture of what we call aggregates. So you've got big stones, little stones, and sand that are glued together with cement. And in well made concrete, you use multi size aggregates or multi size stone and sand, and to minimize the amount of cement holding it together so there's no air pockets or what have you. Because it's the stones and sand that give the strength, and it's the cement that hold the stones and sand together that hold everything up. Inside that, you'll often have reinforcement bar steel, but most of it is in that cement to aggregate relationship.
That's a very clear way to explain it. I don't know if I've heard it explained that clearly before. So, when it comes to concrete, it does sound like it's pretty critical if cement is your bonding unit, then to have that diversity of size. So then you
Yes.
basically don't need as much glue to kind of hold everything together.
And that is the first thing you do when you're trying to decarbonize the cement and concrete sector is you go to more sizes of aggregates and better mixing.
That makes sense. Well, I think you already answered my next question, which was kind of where do we use, some concrete in our economy? And it sounds like it's kind of half and half between infrastructure and building. Um, let's jump from there into kind of like what are the most kind of promising solutions at the moment for addressing concrete's emissions?
No, a great question. So, most of the emissions from cement and concrete come from making cement and very specifically from making something called clinker. It's the precursor material for making cement. And basically, what we do today is we take limestone in a kiln and we heat the ground limestone to 850 degrees Celsius, and then it separates into calcium oxide or lime and CO2. And then the CO2, we just release that to atmosphere typically. And then we take that calcium oxide, we mix it with iron and aluminum silicates, and that's baked together at 1450 degrees Celsius, and that forms clinker. Now, it's 60% of the emissions from cement and concrete making are from that CO2 that goes off into the. This is in a best available technology, a very efficient plant, which is what most of the plants are in the developed world today. 60% of the emissions are that CO2 that goes off from the limestone. 40% is from the heat to do all this. In a less efficient plant, that heat component will be larger.
Okay. So basically what's going out sort of the stacks, if you will, from these kilns, that CO2 is the bulk of it, but then there's the other major component is heating, right? Generating the
Yes.
heat to get these things up to temperature.
Yep.
Okay, that makes sense. And I guess for just general awareness for folks, how much of the globe's, emissions, greenhouse gas emissions are currently kind of tied to concrete production?
It's roughly 8%.
So it's roughly, the emissions of almost the European Union. I think the European Union is about 9% now. So wow, that's massive.
It's big.
Well, let's pivot then into sort of solutions. What's out there today that's kind of promising? Kind of where are we in terms of stages of development?
Okay, so this is where already today we do what's called clinker substitution. In North America, most of our cement is almost pure clinker. In Europe, though, they have 5 different classes of cement that allow different mixtures of other stuff in with the clinker depending on what you're doing. If you've got a lot of blast furnace slag to work with, you can do up to 95% substitution. Fly ash, maybe 30-40%. So there are these different mixtures depending on what you're using it for, what you're trying to hold up with the concrete. There's different mixtures, and it'll still work and it has lower emissions. Now, what's really interesting is there's a Swiss organization, LC3 cements, or limestone calcined clay cements, and what they want to do with up to half the clinker is you replace that with 1/3 ground limestone, 2/3 calcined clays. And that 1/3 to 2/3 can replace up to half the clinker in normal cement without affecting its performance. So right off the top, and this stuff meets US performance standards already, right? It's a matter of getting architects, civil engineers, structural engineers, and construction companies used to working with it and getting it into projects. So we could literally cut half the emissions from cement as soon as we can get this stuff into the market. So that's the first big one. The second it's second through 10th, is there's a whole bunch of alternative chemistries coming up. First of all, you've got a couple of US companies that are trying to figure out how to get the constituents of cement without heating limestone. Like all those emissions all those big emissions I talked about earlier come from heating limestone and releasing CO2. Farther down the road, there are other even alternative chemistries for making cement, but we tend not to focus on those because they change how we do construction, and we don't really want to, like, there's too many options that don't require us to change construction, that we want to get those into the marketplace first.
Gotcha. So some questions about chemistry, and some folks may not be, super comfortable with chemistry, but it sounds like there's an option to today kind of switch out about half of the cement that we need, or half of the materials we need to produce cement with alternatives that don't produce those CO2 emissions. And then it sounds like the limestone that's in, as a product of this process, minimizing that is really where you have big gains in terms of eliminating carbon emissions.
It's the limestone heating. The other thing that's available to us is to apply carbon capture and storage, where at the end of the kiln, you grab all the emissions, you separate out the CO2, and you put it underground. So cementitious material substitutes, alternative chemistries, and CCS. Between the three of those, we have all the options we need. Now, the thing is, though, to add CCS to a cement plant is going to add probably somewhere around $400 to $700 million to it, and probably double the cost of the cement.
Wow. Okay. So from a cost perspective, it sounds like the option number one, which is reducing your, sort of need for cement in the process, is kind of is the ideal solution, because it's, you maintain the strengths that you need to, and it sounds like it doesn't have a big impact on cost. So just making sure I understand kind of the different possibilities. If we were to talk about this in terms of like glue, it sounds like, we have materials we can substitute in our glues, so we don't need as much of it if the cement's the glue. It sounds like there's different types of glue that we could make that would still serve the same purpose. And then, then there's these emissions that come out at the end of the process of making this glue, which is cement, and then, capturing those emissions and putting them back into the ground.
Yeah, the interesting thing is that capture equipment is very expensive for the producer, right? So for the person who owns a cement plant, but it adds very little to the cost of a road, a bridge, or a building, right? So if we can connect that very small increase in cost at the end use with the very high increase to the producer, and make a contract between the two of them, we can make this happen. The problem is right now is the cement producers sell into a homogenous market, and their product would cost twice what dirty cement costs, and therefore they won't sell any, right? So if they can connect through to people who are willing to buy the very low emissions cement, who are willing to pay that little premium, it will make all the difference. And that it's the same with steel, right? Can you get your green steel through to a car maker who's willing to add a couple $100 to the car because they know the consumer will pay for it?
So then is that really about kind of the purchasing side then, like having, let's say, governments commit to buying this greener material, and then having, that, you say that cost be able to pass back through to the producers so they're able to cover.
Yep. And already in the U.S., there's a federal level executive order heading to, and it's further to be defined. California and a couple other states are working towards that. Several European jurisdictions are working towards that. But it takes time to get these things through. And you almost need the signal that the willingness to buy and the willingness to pay to be there before the cement makers will take the big risk of investing several $100 million more in a plant. Or like switching to the different glue, which doesn't cost them anything, but it has market risk attached to it, right? Or switching to, or installing capture equipment, which adds $500 million to their plant, which has a very big financial risk to it. They'll do it, but they have to know they're going to get the necessary price for it.
So if we're looking at kind of the chicken and the egg formula, we need the government really to commit to or make long-term commitments in terms of being able to purchase this material so that these folks can feel comfortable, getting out the checkbook for, hundreds of millions of dollars.
Yeah, exactly.
So it feels like there's a little bit of buzz about like storing carbon in concrete. So I want to give you a chance to kind of riff on that because I think
okay.
I've seen some people talk about it like, oh my gosh, this is going to save the world.
Yeah, there are several companies that do this. Include the preeminent company at this point is a Canadian company out of Halifax called Carbon Cure. And what they do when the cement is curing is when they pour the cement is they inject some CO2. Now, what that does is it hardens the cement faster and it makes better quality cement, a harder cement. The amount of CO2 going in is absolutely tiny, but it's what it does to the chemistry and the reaction that allows the builder to use less cement where they might have before.
So really the CO2 is this strength enhancer, and that's really where you get the savings in using less material.
And this brings up another thing. A lot cement structures over their lifetime, the unreacted lime and other materials in there will pull CO2 out of the atmosphere and react it. If you've ever looked at an old bridge or a crack on a concrete structure and you'll see that solidified, it's like white stuff or lime on there, that's carbonation happening right in front of you. It's where CO2 is literally being pulled out of the air and re-solidified. So some people say up to 80% of the CO2 that was emitted when making the cement will be reabsorbed by the structure. Some say only 20, but I think it's dependent on how porous is the structure, how exposed it is to the air. Like if lots of air can get at it.
So as we're talking about these different solutions, I can't help but wonder, being somebody who, thinks about the reduce and reuse before the recycle, are
Yeah.
there other kind of areas in sort of the life cycle of concrete that we should be thinking about in terms of reducing emissions, right? Are there ways to reuse old concrete or recycle it so that we're not having to create as much of the cement in the first place that, generates these emissions?
No, absolutely. Before you even talk about production, at the front end, we should be designing buildings and infrastructure, what have you, to minimize concrete use. We use about 3 times too much typically.
Oh, wow.
Simply because it's cheap, it's very resilient, but we tend to use too much of it for that reason. And just having an architect consider minimizing the use of concrete and even using CAD CAM tools where you say you print a structure or you precast it just so that the concrete's there for the down forces, but you don't have all this extra filler concrete there that's not necessary for the strength of the structure. So right up front, very conservative estimates are that we can cut concrete use by about 25% just in design, right up front.
Wow.
On the back end, when we're done with a concrete structure, there's often quite a bit of unreacted cement in there. So if you grind up that concrete, you can recover the unreacted cement and you can recover those aggregates, the sand, the small stones, and the big stones, and reuse them. And that actually has a side benefit that you don't have to go quarry more aggregates, dig up a stream bed, pull out a hillside. It's getting harder and harder for concrete companies to get aggregates. So if you can recover those aggregates and reuse them, it means you don't have to dig another hole, basically.
Okay, so both on the front end, using less of it, being more efficient with it in terms of design, and then on the back end, it sounds like there is an opportunity to really recycle or reuse some of these materials.
Yes.
What's necessary to get that kind of jump started, right? I mean, is it something that's done at a small scale, kind of been proven out, but just needs to be scaled up, or?
Okay, so building codes. Where building codes should encourage this and not discourage this. So that right up front, you need to put the discretion in the hands of the architect, civil and structural engineer. They need to prioritize minimizing the use of concrete, but you have to allow them to do that. On the back end, cement and concrete companies have often been not allowed to reuse aggregates. They've been forced to go mine new aggregates. And part of this is because it's gotten more and more expensive for them to do that. They've been asking to be able to recycle old aggregates. So it's kind of like with clothes, right? You'll see a little tag saying 100% brand new fibers. Do you necessarily want them to be 100% brand new? Does that make material better for you? Sometimes it's, if you can recycle older fibers, they're just fine. That's exactly the case with aggregates.
So on that back end piece of it, then it's making sure there aren't barriers. Then if I'm a concrete manufacturer, that I can go and partner with the municipality where I have my plant and be able to take down that old structures, use some of that to build the net new structure.
Yes.
So, Chris, as we're talking about this, technology's there. It sounds like the solutions to help, implement the technology are there. And so I guess I'm wondering, from your perspective, what are the things that, and maybe we've talked about them already a little bit, but what are the things we need to do to really accelerate this, decarbonization of concrete?
No, absolutely. Well, okay. A, revise the building codes. B, get green procurement going. C, when it comes to the expensive stuff like putting CCS on cement plants, you're going to need some specialist policies. Like, we're struggling to get strong carbon pricing in North America, and that's just a political reality. Probably in my lifetime, it'll never be strong enough to pay for decarbonized cement plants. But what you can do is put on what are called carbon contracts for difference or production contracts for difference, where for every ton of clean clinker or clean cement they put out, they get a guaranteed adder for so many years. This is how they got wind and solar going in Europe, and specifically offshore wind around the UK. So the UK would say, we've got 1,000 gigawatts or 1,000 megawatts of space here for wind turbines. They would put it to the open market saying, what's the minimum price that you need to generate? And companies would bid in, and the lowest cost companies, they would get that minimum price. If the market price was over that, the government would collect the extra. But if the market price is under, they make sure the companies get that extra they need. The same thing could be done for cement. Another thing we're working on is, so California has this zero emissions vehicle standard that was used to bring zero emissions vehicles onto the market. Car manufacturers that wanted to sell in California first had to do 0.5%, then 1%, then 2%, then 3%, then 5%. The same thing could be done with cement plants. If you want to sell cement in California, you have to have a ZEC credit, a zero emission cement credit on hand that says this amount of zero emission cement was produced somewhere in the jurisdiction.
So just unpacking that a little more. So, I know we talk a lot about the value of a carbon price, but it sounds like, while a carbon price might be good for things like driving electric vehicle, uptake, cement, you're talking a lot higher price on carbon. So probably not the tool that we need at this point. And instead, it's really creating these markets where government is ensuring that these, manufacturers get the price they need to be competitive, or you're basically mandating and saying, hey, a certain amount of what you bring into this state or this country has to be zero emission concrete. And then you just kind of slowly ratchet that percentage
Right.
up.
Exactly.
So while, many of us aren't going to be consuming a lot of concrete ourselves, wondering, if we can help push concrete in the right direction here. It sounds like, if we can advocate for cleaning up building codes and then maybe pushing our, local or state or what have you government to purchase green cement.
Yeah, no, absolutely. And to my mind, this is something we should be able to get by, every country's got its own political structure going, but we should be able to get bipartisan consensus around, right? It's just buy clean, buy domestic. Right, because that way you can control the environment, you can control the technologies. The costs are very small. They're a lot for the producer, very small for the users. If we can bridge that gap, and this is putting domestic workers and investment to use, cleaning up the local environment. It has a lot of local air quality improvements as well that come with it. the trick is citizens have to contact their representatives, pick up the phone or write a letter, what have you. That's why they're there. They are your democratically elected representatives.
All right. Well, we'll all try to do our part then to pick up the phone, send those emails, and call for a greener concrete.
There you go.
Well, Chris, thanks for coming on to help break down a pretty complex topic, but it sounds like one where we've got some momentum in the right direction, and be interested to hear how things shake out.
My pleasure, Jason.
So, Thomas, what did you think of the interview with Chris?
Yeah, Jason, very informative. I tell you what, I really had no idea though the sheer magnitude of this. I mean, really, to put things in perspective, the amount of emissions associated with this are the same as all the light vehicles on the planet. And we spent a lot of time talking about conversion to electric vehicles and stopping the use of internal combustion vehicles, but really, this problem's just as big.
Yeah, it's pretty wild to think about it in that context. Obviously, we're rightfully focused on electrifying transportation, but there are a lot fewer concrete plants out there than there are cars, and so coming up with a good solution seems like you could retrofit it, much more quickly. And as we're talking about, the fact that we use so much of concrete, it's worth pointing out that, carbon isn't the only impact, right? I mean, roughly 10% of industrial water use goes to making concrete. It's actually, believe it or not, creating a global sand shortage. You need, special kind of sand to be able to make it. It has to be kind of the type that comes from riverbeds or beaches rather than the desert. Apparently the sand on rivers and beaches is more angular and that works better with the concrete. But yeah, no kidding. There is a global sand shortage underway to the point where, they're dredging up, rivers and whatnot and causing all sorts of environmental damage just to get at this stuff. And then, even just the aggregate, right? The gravel that goes into the concrete. I mean, every time we need more of that, we have to go cut down a mountain. So I think in addition to the carbon, it's just worth pointing out that there are these other, huge environmental impacts to concrete.
Yeah, because when you look at a normal concrete mix, you typically have about 1 part cement, 2 parts sand, and 3 parts aggregate or gravel. So really, for every unit of cement powder that we're using, there's 5 other units of other minerals that are put into this.
Which leads obviously to the question of, well, what do we do in terms of solutions? And Chris was great about laying out some of the promising technologies that help us reduce the carbon emission side of things. I think, and he spoke to this as well, but what we fundamentally need to do is use less concrete. I mean, whether that's using nature instead of concrete, getting rid of seawalls and growing mangroves instead, or, taking out that levee and using wetlands to absorb floods, or, as he pointed out, using concrete more efficiently. But we got to start with using less of this stuff.
And I think part of that comes back to how we design our cities. So if you look at the moment, we typically build a whole bunch of very low density, single level, or especially in Australia, single level sprawling suburbs that all have concrete foundations in them. And then we build a really high density central business district that has massive concrete structures in it, and structures that do require concrete because they are so tall and you need the tensile strength and compressive strength and so forth that modern concretes can bring. But if we look at the European model, where there's more sort of 3 to 4 story buildings spread throughout the city, that results in a significantly lower concrete requirement, because it can allow you to have, sure, the foundations might still be concrete, but the structures themselves can be timber and hempcrete and other products that are suited to building up to that 3 to 4 story level.
Well, and then not only does it house people in fewer square footage, but then it also has those co-benefits of, making it easier to justify public transportation and, reducing car use, et cetera. So urbanization isn't going away, right? And if you believe the UN projections, they're saying another 2.5 billion are going to be, moving into cities by 2050.
And along those same lines too, like when we build these structures, I think it's very important that we do focus on building for the future. So something that's going to have a long operational life and a flexible operational life, so that we're not having to decommission and rebuild these structures every 40 years or whatever it might be. So solid planning around current use and future use for these structures.
Yeah, completely agree. And then as Chris points out, being able to, if we do have that structure that has to come down, being able to recycle that, that concrete and, feed the aggregate, sand, leftover cement back into the process again. So we're not having to go out and get net new materials.
Yeah, and along that line, talking about recycled materials, there is a concern in my mind about the dependence upon fly ash as a substitute for cement powder in green concretes. And the reasoning there is that it creates demand for a resource that we don't really want to be creating demand for. The sooner we can let these coal-fired power stations that are creating this waste fly ash go out of business, the better. So, we don't really want to prolong their demise, so to speak.
Yeah, also a great point. I mean, if all the coal plants were sort of decommissioned tomorrow and we had this huge pile of fly ash, and fly ash, for folks who may not know, is just what's left over after you burn the coal, kind of like what's left over in your barbecue, after you burn your briquettes. But yeah, we don't want to be creating demand streams that encourage, more fossil fuel use. So I guess, all this leads to the question we always try to ask, which is, what can we do? And this week we've got two suggestions. The first is if you're here in the US, email President Biden and tell him the US needs to start requiring low carbon concrete in federal projects, as well as recycled materials where possible. And we'll have talking points on our website to assist with that, as well as a direct link to be able to email him. And our second option this week is really about, thinking through your own use when you get ready to do a project that requires concrete, and looking for alternatives either to the concrete itself or finding concrete that has lower embodied carbon. And we'll have links on our website to some sources that can give you ideas on that sort of thing, whether you're building a driveway or house. I don't know, Thomas, you have any other thoughts there?
Of course, Jason, as you know, I'm a huge fan of hempcrete. Sure, not a direct replacement for concrete, but might mean that you're not using concrete blocks in the walls anymore, and instead you've got a natural and insulating product made of hempcrete instead.
Yeah, there really is no limit at this point to the substitutes that are being worked on out there. And I'm, maybe an engineering geek, but super excited to see where, things land and what we're using to build our structures, even 10 years from now. Well, that's a wrap. Thanks for tuning in. Come back and join us again on April 11th when we'll be dropping our next episode. Climate Optimists is made possible by Climate Stewards Collective. You can find us on the web at climateoptimist.co. And don't forget to follow us on social at Climate Optimist Podcast.